James Webb Space Telescope found an insane discovery and left scientists speechless. NASA has been inserting telescopes into orbit for years. However, the James Webb Space Telescope is the first to have capabilities that can compete with it. The JWST has never been seen with such excitement despite its costly price tag and extended development period as an observation facility. However, a surprising finding regarding the warp bubble already demonstrates the value of the larger and more powerful telescope. What exactly is a warp bubble? So what discoveries have the JWST made so far? Welcome back everyone. In today's video, we will be sharing an insane discovery that left scientists speechless. The human species is curious and constantly seeking to learn more about the world. Curious minds are drawn to the unknown. Is it possible that some of the aliens with whom we share the universe possess cognitive abilities comparable to our own? Exists a possibility that we have discovered an exoplanet containing microbial life? The size of the universe, though, makes space travel difficult. In the big picture, Mars isn't that far away. Volunteers for Elon Musk's colonization effort will have to travel through the dangerous atmosphere of deep space for more than 5 months before arriving in their new home world. Imagine though, supposing you want to visit Proxima b, the exoplanet nearest to Earth using current technology. NASA has long been involved in sending space telescopes into orbit. Astronomers utilize the Hubble, one of the most well-known space telescopes, as it orbits the Earth to investigate remote regions of the cosmos. However, NASA is the kind of agency that can't help but keep launching satellites regarding the warp drive. Compared to prior satellite telescopes, humanity now possesses a new, substantially more sophisticated tool for studying far-off cosmic objects. The James Webb Telescope will replace the Hubble as the most potent observatory in orbit. Astronomers can now see further into the past thanks to the JWST, which has made it possible for scientists to study the process of star creation at the moment the universe was created. Its 100 times more power than Hubble enables us to look back in time beyond the 330 million-year-old perspective of the universe provided by the sixth star. Keep on watching if you're curious about how the JWST can view the past billions of years. It's because light from distant stars has taken billions of years to reach Earth. The far-off stars will disclose their appearance from billions of years ago, when viewed in this light from a distance of kilometers. Nevertheless, a few of them might have passed away. The JWST's initial set of images, which will be used to demonstrate its capabilities, have been made public by NASA. The bright areas of space known as the Carina Nebulae are among them. An expansive cloud of gas and dust located roughly 7,600 light-years away from Earth is home to several bright stars that are several times the size of our Sun. The pictures will also show the Stevens Quintet, a galaxy about 1 million light-years away. The reciprocal attraction of their gravitational pull has twisted the shapes of 4 of the 5 galaxies in this group, causing them to be involved in a complex dance. Soon, breathtaking images of the galaxy cluster SMACS 7, 2, and 3 will be accessible. An unusual phenomenon, the light from objects behind this galaxy cluster is distorted and amplified by the cluster's galaxies. This characteristic enables telescopes to find distant, faint galaxies. The JWST truly shines in this area. The warp bubble, however, stands out from all other discoveries the JWST will make. We'll start by explaining what a warp bubble is. Although a solid understanding of mathematics is required for a comprehensive understanding of the subject, we will settle for a straightforward definition for the time being. In a warp bubble, you're not traveling at the speed of light. Instead, you're only moving in a compressed space bubble that is extended in the back and compressed in the front. This accelerates the bubble and its contents beyond the speed of light. Why are warp bubbles such a big deal, you may inquire? They do it by resolving a significant issue with moving faster than the speed of light, which slows down time. Please allow me to clarify what this means. Imagine being able to travel faster than light. Your 3-hour excursion to a tropical paradise would seem like years on Earth, since everything outside your ship would speed up. You should probably call it quits on all your relationships before you go if you want to follow all physical laws and travel at the speed of light. Contrarily, since the space inside a warp bubble doesn't alter, it doesn't have this issue. Therefore, even if you fly at warp speed for an hour, everyone else only experiences that hour. Fans of Star Trek are likely familiar with the idea of warp speed. There have been 10 television series and 13 movies set in the Star Trek universe since the first episode aired in 1966. All of them feature spectacular futuristic technology known as warp drive. The heroes of the novel travel between planets in swift, powerful spacecraft while corresponding with an alien crew. People are drawn in because the plot wouldn't make sense without the torsion engine. the universe is impossibly vast, bizarre, and mysterious. The vast distances between them makes it practically impossible to travel, even if you want to reach the next star. Proxima Centauri, 4 to 5 light years away, is the next star we can study. Reaching that star would require approximately 4 to 5 years of travel at the speed of light. Since light travels at a full cosmic speed and serves as a kind of global speed constraint, any other approach takes longer. The long journey into the intergalactic abyss would take around 80 years, even with the fastest space probe currently in development. Thus, staying near Earth and its surroundings environment makes sense. The Star Trek team found a way to reduce their travel time, so they didn't stay close to home. They didn't bother to hang around as a result. The torsion engine, which uses warp drive technology, juggles Earth, space, and time, and the outcome is exhilarating. Before the last decade of the 20th century, scientists had given hope of ever creating a warp drive. Where do warp bubbles fit into the overall picture? Check out Proxima Centauri, 425 light years away and the star closest to Earth. That is roughly 40 trillion kilometers or 25 million miles. With a top speed of 450 miles per hour, the Solar Probe will be the quickest spacecraft ever created, traveling from Los Angeles to New York City in under 20 seconds. But getting to Proxima Centauri will take you almost 6,663 years. However, according to the spacecraft's internal clock, you may get to Alpha Centauri in a month if you use warp bubbles. With the master clock at mission control, the scientist who had the idea that stunned the scientific community worldwide in 1944 was Miguel Alcubierre. A next-generation episode where massive weights may bend space and time inspired Alcubierre's doctoral thesis on Einstein's general theory of relativity. He made the calculations right away on a scrap of paper, and later that year, he published the results in a scholarly publication. To speed up travel, you need exotic matter with negative gravity. The spacecraft would be enclosed in a bubble of flat space-time by Alcubierre's warp drive, which would twist space-time around the bubble. A ring of negative energy density, or the hypothetically feasible form of matter known as the negative mass, would be needed for a warp drive to work. Scientists have never observed negative mass. Therefore, this leaves us with just the latter scenario. A warp drive can produce negative energy by causing an imbalance between particles and antiparticles, but this requires a lot of mass. Alcubierre's warp drive would use this negative energy to build the space-time bubble. However, the warp drive would need a lot of matter to produce enough negative energy. Alcubierre calculated that 1 times 130 kilograms of matter would be needed for a warp drive with a 100-meter range. It seems inappropriate for you to enter this area. Fans of the warp drive have yet another reason to be optimistic that they will live to see a real warp drive built and used for scientific research. The process for creating a functional warp drive might have been stumbled upon. It seems unlikely that warp bubbles will ever be used in practice. The amount of energy generated during the experiment made Alcubierre's idea of warp speed technically feasible. Alcubierre's feasible idea for a warp drive that could go faster than the speed of light without defying known physical laws was also something White was familiar with. He was aware that the concept had been mocked for its reliance on theoretical materials that had never been created in enormous amounts of energy. Alcubierre's original measure was improved by White and transformed into a canonical version, which significantly decreased the need for unique resources and energy. The initial theoretical design was officially renamed the Alcubierre-White warp drive due to the altered concept. It also gave scientists and science fiction fans hope that a workable warp drive might be someday developed. That is all for this video. We will be back soon with another informative video. Don't forget to like and share this video. Until next time.